In order for employees of a company to work in a foreign office, they must take a test in the language of the country where they plan to work. The data below shows the relationship between the number of years that employees have studied a particular language and the grades they receive on the proficiency exam. So an employee with a lower number of years studying the language has, so the lower the number of languages, as I go this way, generally speaking, a lower test grade. Okay, does this graph exhibit a linear or non-linear pattern? So I think that this is a pretty straight line if I was to draw a trend line. I could check by going on my calculator, going to the table. This is my X, this is my Y, and I type in my points. Got my Y value, type in my points. Menu, 4, 1, and linear, we press 3. X is X, Y is Y, enter. So it's telling me, oh, this data point's wrong. It's telling me that my R value is 0.93. So that's pretty close to 1. So I would say that is a pretty strong relationship. Those lines are fairly close to that straight line. R equals 0.93 matches a linear trend line. Okay, is the graph representing a positive or negative relationship? So this is positive because it's increasing. And also it has a positive R value. Does this imply a cause and effect relationship? So for it to be a causation, it has to happen. So if you've been studying the language longer, do they have to have a higher test score? Well, here I can see somebody that studied for 3 years got a 72, but someone that studied 4 years got a 68. So no, there's a strong correlation, but not a causation. Does not have to happen. Describe the relative strength of the association between the variables. This is a positive, strong association or correlation. And I know that because 0.93 is close to a positive 1. Which of the following situations is an example of a causation? And for causation, has to happen. So, an increase in the total rainfall means an increase in the days of cloudy weather. So, normally, yes, the more rain you have, the more cloudy weather you have, but it doesn't have to be that way. An increase in the amount of snow means a decrease in the number of days until Christmas. Generally speaking, it's going to snow more the closer you get to Christmas. Sometimes it also snows after Christmas. It doesn't have to be that way. We don't get snow here in Houston most years. All right, an increase in the number of days of birthdays that have passed means an increase in your age. So if you have had 3 birthdays or 4 birthdays or 7 birthdays, your age is 7 or 3 or 4. So yes, if you have had the birthday, you have to be older. A decrease in the number of calories consumed means an increase in the feeling of hunger. So generally speaking, yes, the more you eat, the less hungry you feel, but a lot of it also depends on what type of food you're eating, right? There's such thing as empty calories. So just because you eat more food does not necessarily mean that you are not as hungry. This scatter plot could show the relationship between which 2 variables? The speed of an airplane versus the distance traveled in 1 hour. So as the speed increases, the distance traveled in 1 hour should also increase. This is a negative relationship. So one of these needs to be going down. The outside temperature. So as it gets hotter outside, the air conditioning costs more. Okay, age and adult, as you get older, generally speaking, you get taller. Distance traveled. The further you travel, the gas remaining in the tank, your gas decreases. So it is D. That is a negative relationship. The following scatter plot shows the weights and lengths of some dinosaurs. Which statement accurately describes the information in the scatter plot? The information shows a positive correlation. The weight of a dinosaur tends to increase according to its length. The information shows a negative correlation. These points are definitely not going down. It's not negative. The information shows no correlation. The weight and length vary according to the type of dinosaur. I mean, that could make sense, but based off the data, that's not what I'm seeing. The information shows no correlation. Again, I would say there is a correlation. I can see that these are lower, these are higher. Generally speaking, the length does attribute to the weight. Identify the data sets as having positive, negative, or no correlation. So the number of hours a person is driven, so the longer you drive, the number of miles driven increases. So that is positive. The number of siblings a student has, so the more siblings you have, their grade in math class. I have no idea because there is no correlation. Those are not related at all. The age of the car, so the older your car is, the value of the car decreases, generally speaking. Yes, I know there are classic cars, but for most cars, this is what happens. So this is a negative correlation. The number of weeks a new version of a phone has been available to buy. So the longer the phone has been available, the weekly sales normally decrease. There's a huge rush that go and buy the phone right when it's released, and then it kind of dies off slowly after that. So this is a negative correlation. Describe each scatter plot using the following letters. Write the letters by the name of each graph. Little or no correlation. So this right here is all over the place. This would be little or no correlation. Negative correlation. This is generally going down, which is a negative correlation. And then positive correlation, that's going up, so that is generally a positive correlation. Here, again, going up, so C is positive. Here, this is all over the place, so this would be little or no correlation. Here, generally speaking, is going up, which is positive, so C. This, generally speaking, is going down, which is negative, B. This is straight across, which we call a constant correlation, D. Generally speaking, this is a positive, so this is C. It also asks us to circle the graph that has a strongest correlation. So 16 and 12 are both pretty strong. I'm going to go with 12, but I would have accepted either, just because they are both pretty strong. A fish tank holds 30,000 gallons of water. It is leaked and losing 1,500 gallons per hour. Write a recursive rule for the amount of water in the tank. So recursive always starts Tn equals Tn minus 1. And because it's losing, we're subtracting 1,500 each time. Write an explicit function rule. So Tn equals, it's starting with 30,000. And we're losing 1,500 each hour. I'm not going to do n minus 1 because that's not how much it has after 1 hour. That's how much it has at the very beginning. How much water is in the tank after 14 hours? So, there's two ways I can do this on my calculator. I can just go to the calculate screen and type 30,000 minus 1,500 parentheses. So it wants 14, so I put 14. So there's 9 1,000 gallons. You could also go to the graph, and we're going to type in the function 30,000 minus 1,500 x. Click Control T, and then after 14 we can see that it is at 9,000. How many hours until the tank is empty? So here I'm looking, when is there 0? And that's at 20 hours. John is trying to increase his bicycling stamina by adding 0.25 miles to his ride each day. He starts out riding 4 miles a day of a 30-day month and then increases his ride by 0.25 miles per day. Write the recursive rule. So Tn equals Tn minus 1, because that's how recursive always starts. And we're just adding 0.25 miles per day. Write an explicit function rule. He starts out riding 4 miles on the first day. So starts off at 4 on day 1 plus 0.25 times n minus 1. This time I am using the n minus 1 because this is on day 1. On what day will John ride 13 miles? So I'm going to come over here, Control T, delete the function, so menu 3.1, 4 plus 0.25, parentheses, x minus 1. Control T. So on what day will he ride 13 miles? So going down until I see 13 miles, which is my y. Day 37. How many miles will he ride on day 62? So now they're giving us the x, and on day 62, he's riding 19.25. Complete the given table for a house with a depreciation of 15% per year. So because I know it's got a percent, I know that this is geometric. And because it's depreciating, that means it's taking away from 1. So Tn equals Tn minus 1 times 1 minus 0.15. You could also simplify this and say Tn equals Tn minus 1 times 0.85. Write the explicit or function rule. So Tn equals, it's starting at 330,123, multiplying by 0.85, and I'm just going to do to the x. I don't do the n minus 1 because this is at 0 years, not at 1 year. So what is the value after 8 years? So Control T, delete this, menu 3.1. So we're starting off, parentheses 0.85 to the x, enter, Control T. So after, 0, I can see that it's starting at the right spot. After 1, what I'm doing is I'm taking 330,123 and multiplying by 0.85. And I get 280,500. After 2 years, now I'm taking this 280,500 times 0.85, and I'm getting 238,425. Then I'm taking this 238,425 times 0.85, and I'm getting 202,661. Then I'm taking 202,661 times 0.85, and I get 172262. Then I'm taking this 172262 times 0.85. And I get 146423. So what is the value after 8 years? So after 8 years, the value is 89921.90. Okay. How many years will it take for the house to be worth less than $3,000? So I just keep going down. Oop. Right here, it's less than 3,000, so 29 years. Because after 29 years, it'll be worth $2,962.53. Complete the given table for bacteria that decays and maintains 85% of the bacteria per hour. So for the recursive rule, Tn minus 1, they're giving you the rate. It's maintaining 85%, so 0.85. So notice that these have the same recursive rule because this one told you it's depreciating by 15%, so we have to take away 15%. This is telling you that there actually is 85%, so it's just a straight 85%. So Tn equals, it's starting with 5,000 bacteria times 0.85 to the x, because that is 0, not 1, so we don't need the minus 1. So, Control T, menu 3.1, my formula is 5,000, parentheses 0.85 to the x. Control T. So after 9 hours, 1158.08 bacteria, which really you can't have 0.08. How long until the bacteria is less than 100? So right here, 25 hours. There are 85.99 bacteria. Alright, let's go on the table. So after 1 hour, I'm taking this 5,000 times 0.85, which is why after 1 hour, there were 4250. Then I'm taking 4250 times 0.85, and I get 3612.5. Then I'm taking 3612.5 times 0.85, and I get 3070.63. Then I'm taking 3070.63 times 0.85, 2610.03. Then I take 2610.03 times 0.85, and I get 2218.53. George wants to save up $8,000 to buy a car. He already has $1,200 in savings. Which scenario, A or B, gets him to his goal faster? All right, in an effort to help Jordan save money, his parents will pay him 15% interest each month on the money that he accumulates. So he's starting off, so Tn equals, he's starting off with $1,200, and he's increasing by 0.1, so 1 plus 0.15 to the x. This is after 0 months, so we don't need to do the n minus 1. So let's see, how long will it take him to get reach his goal using that formula? So menu 3.1, 1,200 times 1.15 to the x. Control T, and he wants to get 8,000. So he will have $8,000 after 14 months. Here, Jordan will be babysitting his younger siblings on a regular basis and will add $400 to his savings every month. So TN equals, he's starting off with $1,200 and he's adding $400 each month. Menu 3-1, $1,200 plus $400 each month. Control T. So to get to that 8,000, it will be after 17 months. So he is better off if his parents will give him 50%. Jordan gives his younger brother some advice about saving for a car. He tells him to start out now saving $1 this week and then double the savings each week. Make a table of values that reflect this scenario. So on the first week, he should save $1. On the second week, he should save $2. Then he should save $4. Then he should save $8. Then he should save $16. Then he should save $32, doubling each time. Give a recursive rule that will define the scenario. So TN equals, so at week 1 he has $1 times 2 to the n minus 1. Oh, sorry, that is the function rule. The recursive rule is TN equals TN minus 1 times 2. How much money will his brother save on week 12? So I'm going to use my function rule. Sorry for getting those switched up. Menu 3-1. So he has 1 times 2 to the parentheses x minus 1. Control T. Let's just make sure this table matches. 1, 1, 2, 2, 3, 4, 5, 4, 8, 16, 32. So on week 12, his brother will save $2,048.